So let's start with this case now. A 4 into 4 matrix has 4 horizontal rows and 4 vertical columns. Aij represents the value of an element in the cell in the ith row and in the jth column. For example, A23 means second row, third column. Saral, a logical enthusiast, is trying to fill up such a matrix so that each element is a multiple of I plus j. So A23 will be a multiple of 5. A34 will be a multiple of 7, so on and so forth. Also, he is trying to fill the matrix such that every number is distinct and is greater than 0. Finally, he filled up the matrix such that value of the largest number in the table was minimum possible. The largest number should be minimum possible. After that, there are 4 or 5 questions on this. So this is the matrix that I have already made over here. Here you would see there is only one multiple of 2 that we need in this table, which is in A11. There are 2 multiples of 3 that we need over here, that is A12 and A21. There are 3 multiples of 4, there are 4 multiples of 5, there are 3 multiples of 6, there are 2 multiples of 7, and there is only one multiple of 8 that we are looking for in this complete table. Okay, and we are trying to keep the largest number minimum possible, that also is there. How do we start in these cases? So in these cases, we always start with the one where we need the largest possible number of multiples, which is in case of 5. So if I need 4 multiples of 5, what can they be? The smallest possible 4 multiples of 5 are 5, 10, 15 and 20. Okay, they are 5, 10, 15 and 20. These are the smallest 4 multiples of 5. So of course, I would be needing all 4 of them. This is the minimum possible that I would be needing here, and probably I have to hide myself if I want to write the other things. If I look at the 3 multiples of 6, what are the 3 multiples of 6 that I can have? If I am trying not to go above 20 now, so I can take 6, 12 and 18 over here. I hope you are getting my point. I can take 6, 12 and 18 so that I don't go above 20. The 2 multiples of 7 that I can take, they can be 7 and 14. There are 3 multiples of 4 that I am looking here. So I can take 4, I can take 8, but I can't take 12 because 12 is already taken by 6. So I can take 16 then. This is the minimum possible number of multiples that I am having till now. Okay, these are the minimum possible number of multiples. Then if I look at the multiples of 3, what are the multiples of 3 that I can have over here? The multiples of 3, there are only 2 multiples. I can take 3. I can't take 6, which is already here, but I can take 9. So 3 and 9 are the 2 multiples of 3 that I can have. I now need just a multiple of 2, which can be taken as 2 itself, and just a multiple of 8. Now that multiple of 8, I can't take it as 8 because it is already used here. I can't take it 16, it is already used here. I will have to take minimum 24. That means I will have to go above 20. I do not have an option. Above 20, I will have to go in this case. So by that logic, I can say the minimum possible largest number that I have to use is 24. See, the point is, if let's say I take 16 here and I do not take 16 here, then I will have to take 24 over here, right? That has to be taken at one of these places. Let us say I do not take 12 here and I take 12 here. So 4, 8, 12 are there, 16 is here, but in that case I have to take 24 here. So in any case 24 has to be taken either in a multiple of 4 or in a multiple of 8 or in a multiple of 6. At one of the places I will have to take it. So looking at these things, I can answer all these questions. Now look at the first question. What is the value of the largest number in the matrix? So if I talk about the largest number in the matrix, as you can see over here, the largest number in the matrix is 24. So my answer for this question is 24. The largest number in the matrix is 24. Here's the next question. Which of the following numbers might not be used in the table? Okay, let's check that. 8, 14, 18 and 24. Which of the numbers might not be used over here? The multiples of 5, I can take 5, 10, 15 and 20. Now 24 must be used. I cannot say that 24 might not be used. Similarly, let us say I do not use 8. If I do not use 8, the multiples of 4, I will have to take 4, 12 and 16. In that case, if I take 4, 12 and 16 here, then in his case, I cannot take 12. I will have to take 6, 18 and 24. then the multiple of 8, I would neither be able to take 8, not 16, not 24. I will have to take a number which is above 24, right? That's not a possibility. Similarly, let us say I do not take, let's say I do not take 8 and I take 4, 16 and 24 over here. Then 12 has to be taken over here. I will take 6 and 12 over here, but I cannot take 24. So 6, 12 and 18 are taken over here. So what can I take once again over here? I cannot take 8, I cannot take 16, I cannot take 24. So what would I take? Here I will have to take 8 if I have to keep it below 24, all the numbers. So therefore 8 again is a number which has to be taken. Question is saying which might not be used. 8 has to be used, 24 has to be used. So they cannot be my answers, I can say. Let's say 18 is not used. See, if 18 is not used, from the multiples of 6, I will take 6, 12, 24. If I have already used 12, I have already used 24. From the multiples of 4, I will be taking 4, 8 and 16. So what would I take as a multiple of 8? I will again have to take a number above 24, which is not allowed. So therefore 18 too has to be taken. The only number which might not be used is equal to 14. The only number which might not be used is equal to 14. And how is that? कैसे होता है वो? Without 14 can I work? Yes, if I do not take 14, I can take 7 and 21 over here. Then everything works out. I can take 24 here. I can take 6, 12, 18 here. I can take 4, 8 and 16 here. Yes, everything can be worked out according to that. So without 14 things can be worked out. Otherwise we cannot do it. So my answer for this question is equal to 14. That is this second option. Now, which of the following cells cannot have the largest number in the table? The largest number in the table, that is 24, has to be either as a multiple of 8 or a multiple of 6 or a multiple of 4. So it cannot be a it can be a multiple of 4, can be a multiple of 6, can be a multiple of 8, but it cannot be a multiple of 3. Though 24 is a multiple of 3, but if I use 24 as a multiple of 3, then I will have a problem filling up the other places. How would I have a problem? If 24 is taken as a multiple of 3, then the multiples of 6 must be 6, 12 and 18. So 12 is used as a multiple of 6. Multiples of 4 would be taken as 4, 8 and 16. So what would I take as a multiple of 8 then? 24 is used, 8 is used, 16 is used. I will not have anything to write as a multiple of 8. So therefore, a multiple of 3 cannot be taken as 24. That is the right answer for this question. That's option C. Now, what is the largest possible sum of the 4 numbers in the first row, keeping all conditions the same as given in the data? Largest possible sum of the numbers in the first row. So, I need this sum as to be the largest possible. I am saying I need a multiple of 2 here, a multiple of 3 here, a multiple of 4 here, and a multiple of 5 here. The largest possible multiple of 5 that I can write is 20. The largest possible multiple of 4 that I can write is 24. The largest possible multiple of 3 that I can write is 21. If I write 7 and 14 as multiples of 7, yes, this can be done. And the largest possible multiple of 2 can be written as 22. 24 has already been taken. So therefore, the largest possible sum is 22 plus 21 plus 24 plus 20, that is equal to 87. So 87 is the right answer for question number 14. And finally, what is the product of the numbers in the diagonal starting from A41 going up to A14? So going from A41 going up to A14, this diagonal, what is the product of the numbers in diagonals? This diagonal contains all multiples of 5, and all multiples of 5 are 5, 10, 15 and 20. So their product is 5 into 10 into 15 into 20, which is 15,000. So 15,000 is the correct answer for us. That's the this answer, 15,000 is correct.